Hello, everyone. I'm Brian Behlendorf, Executive Director of Hyperledger, and I want to tell you a story. My parents met at IBM in the early 1970s. My dad wrote COBOL, and my mom was an SE selling System 360s or something. We had punch cards laying around the house that we'd use for shopping lists and other various needs. I remember my dad taking me to work some days during summers when I was in kind of mid-elementary school, parking me in front of a green screen, or maybe it is an amber screen of some sort, and telling me there was a basic compiler and interpreter and prompt, and to try not to get into trouble. I was learning BASIC at the time, so I actually on the TRS-80 that we had at home, so I actually could reasonably entertain myself. But OPSEC, schmopsec, right? I don't recall what I wrote. I just remember writing something that would randomly peek and poke at random addresses and see what would happen. I don't think I ever got to do anything useful, except this one thing I ran would cause my dad to come out of his office cave and punch some buttons on a mainframe every time I ran it and go back inside. So I figured I must have done something interesting. Some of us are old enough to remember back when the word nerd was a slur. It wasn't something you wanted to be called. Computers were not cool. Typing in basic programs from Byte magazine to play a very primitive RPG or downhill ski racer or whatever was definitely not cool. But I still remember having an intuitive sense, as I think my dad did, as a few other kids in the computer lab did, that there was something important going on with all these big computers deep in corporate basement, computer rooms, and the small ones in our homes, something that was going to be worth paying attention to, despite the hazing that we would get from the cool kids. That future was being invented, it felt, albeit quietly, and something about this mattered. Of course, in 1982, the big movie in our lives was the original Tron. Suddenly, nerds were heroes, and computing was no longer about running accounting numbers. Computing was now about good and evil. It was about corporate fascism versus freedom of speech and thought. It was about autonomy versus central planning, and it was about love over hatred. Lots of other movies and before and after explored this domain, from 2001 and Colossus, the Forbin Project, to The Matrix, obviously, and others. But for me and for others, it was Tron. And I suspect that was really kind of a definitional generation. Our mission as nerds in this space became to fight for the user. This fight for computing was a tool for justice over corruption. It was a tool to build this bedrock foundation for the society we wanted to build and the society that did not exist yet, right? But the society we thought we could build with this technology. And we felt like we better get the details right and right from the start, or who knows what would happen. Of course, the internet came around, and you know, the early internet was full of technologies for sending email, the prototype web, all these different building blocks, and it had that sense about it, that it was being built by people who had this intuitive sense that this is not just about building reliable, robust systems, but a fight for the future. So fast forward 38 years to 2020. It's now no surprise to me that so many of the COBOL and mainframe systems running from the late 1970s or even earlier the 60s or the 80s or whatever are still in operation, upgraded piecemeal or even wholly joisted using virtualization, but still performing the thankless, routine, essential functions that modern society depends upon. The technical debt they accumulated, driving things like the New Jersey Employment Office's crunch for COBOL talent, was not due to poor design originally, but to a basic failure of people's part to continuously iterate and gradually adapt and improve these systems. These systems worked so well that the bureaucracy took them for granted, forgot they even existed, really. Truly, they just became like the furniture. They became a victim of their own success. But I love that the open mainframe community is reawakening this domain, the rigor and the design that built the modern computing era at a time when so much of the rest of the cloud world is focused on disposable, inefficient shotgun approaches that treat reliability and robustness as an afterthought at best and as a needless expense at worst. It's like buying a Tesla SUV when what you really need to haul that horse trailer is a Ford F-350. So much of the rigor comes down to that rigor comes down to the word transaction. Transaction. It used to have this sacrosanct place in computing because it was meant to be something you could rely upon, something that was designed to be absolutely impervious to race conditions and mechanical failure. Mainframe architecture, as I understood it, goes to tremendous lengths to ensure that when the systems confirm your rights, It's as good as gold being moved from one safe to another. You can depend upon it. You can run not only banking systems on it, you can run airline reservation systems on it. You can run tax systems on it. Like, this is for the systems of the world, right? Where that kind of variability just isn't tolerated. Then along comes eventual consistency, a well-intentioned approach to scale out for services like Twitter, where if you miss a tweet in your timeline, meh, so what? No one's gold is being moved from one place to another. Then people started building content management systems on top of this, not just for caching, where again, cache misses are a tolerable meh, but for writes of new content. And then payment systems. Payment systems, Bitcoin is not a transactionally coherent system. Transactions are never totally finalized on the Bitcoin network. They are merely probabilistically correct, since across a whole network of possibly unreliable nodes, there's an inevitable possibility that the subset of the network you're looking at is not aligned with the subset I am looking at. Over time, the portion of the network representing the most computing power via proof of work wins out, but you might be sweating bullets for a while if you sold your house for Bitcoin, as that transaction might be blocked or worse, even reversed on another fork of the ledger with more hash power. Imagine if your mainframes only provided probabilistic correctness in their operation or eventual consistency in the database that they run. I'm not talking about stray neutrinos triggering memory faults in non-ECC memory. I'm saying, as designed and operated, Bitcoin and other proof-of-work transaction systems are not designed for the kind of settlement finality that you expect and need, that businesses expect when conducting transactions. For the last 4 years at Hyperledger, we've been working on a different approach to enterprise blockchain systems. Why? Because if business transaction networks go the way of consumer networks, as Tron's master control, go the way of consumer networks, the future looks like Uber and Etsy and PayPal and Facebook, just as centralized and powerful as Tron's master control program. This far into the internet revolution, we shouldn't need centralized architectures that only work reliably if everybody is running on one company's centralized database, SQL or not. We need business networks at least as federated and under-centralized as the domain name system, ideally even more so. In fact, I've started to avoid the term decentralized when talking about blockchains and distributed ledger systems, and recognizing instead that there's usually a need for a degree of loose coordination of some sort, necessarily involving humans. So I've started to call it minimum viable centralization. Open source software actually gives us the perfect template for this sort of minimum viable centralization. Voluntary cooperation via shared validation, developers reviewing each other's patches and signing off on them and merging in pull requests and all that kind of work, with the right to fork. The right to fork guaranteed by the open source license that guarantees you can take that somewhere else if you disagree with the direction that the core developers are taking the rest of the software. We can do that with not just with software source code IP, we can also do that with databases and programs now. That's why blockchain technology is the next logical step in an arc that starts in the 1960s with open standards, or if you want to go way back to the 19th century with railroad gauges and screw shapes and all that kind of thing, to open source software in the 80s and really in the 90s and beyond, to blockchain networks today. This is about building cooperative, voluntary business networks where Teutonic, centralized fascist control over the transactions of the system and the systems of the world are not possible, are second to creating fair, flat, fair market systems. We have a better shot at replicating the kinds of checks and balances that happen in competitive and flat business markets through shared infrastructure like distributed ledger technology. We have a better shot at that than we do at replicating those central platforms. In fact, in the modern financial markets, there are many such market utility operators that we've seen, from DTCC, the Depository Trust and Clearing Corporation, which is a co-op that tracks who owns which shares of public companies on Wall Street, to the original co-op model for the Visa network. Blockchain technology replicates that utility model and that shared network function and that stakeholder type of operation, and it represents that in a technical architecture. It represents that in a way in a clearer way and a more closely aligned way than any SQL database sitting at Google or Amazon would. This isn't an easy case to make to technologists sometimes, but I think it's one that this audience would appreciate more than others. How building markets to be fair, resilient, and just requires thinking about technology that uniquely enables that. rather than on one focused just on speed or cost or capturing maximal returns through rent seeking for my VC investors. But all this enterprise focus on the sanctity of transactions, about replacing old systems, all of this is decidedly uncool. Uncool if you're a crypto bro looking for a quick pump and flip. Uncool if you're a performance maniac to whom a blockchain can never be anything but a slow database. Uncool if you're a VC looking for the next Amazon. And uncool if you're an activist who's seen one too many well-intentioned social impact proposals from people who use magic blockchain tokens to naively incentivize away all the bad stuff. Maybe the mainframe community hasn't had quite the level of inflated expectations driven by quick financial exits that we've had, but I think there's something Tron level heroic in both the mainframe and blockchain worlds. Something about the fight against corruption, the fight against errors that cost people their livelihoods and even their lives. Something core to who we are in the blockchain industry. And I'd argue that we're both two technologies, the blockchain world and the mainframe world, that the cool kids love to hate, but are or are becoming essential to how society works. Now, here I didn't talk at all about Hyperledger really in this talk, but I hope you'll have a chance at some point in the next few weeks to take a look at what we're doing, the kinds of problems people are solving with Hyperledger technologies, the way we're bringing rigor and trust to markets and problems where trust is the key challenge. Please join us if you're interested. Thanks.